The idea of expected value being used in business as a risk management tool is so important. We want to give you a couple more examples to help you cement it in your mind. So here we have an oil company that is considering 3 sites on which to drill, and they're described as follows. So site A, if oil is found, there's a profit of 80 million. A loss if no oil is found of 10 million, and the probability of finding oil is 0.2. And you can see site B and C have similar probability and profits. All right, so what we want to do is construct a probability distribution of the profit for each of the sites. Now remember, profit is gain and, well, it's gain take away loss. It's revenue minus cost, right? All right, so let's look at site A for starters. So the profits for site A and the probabilities for site A. If we make money, right, if we find oil, we make money and we have a positive 80. If we lose oil, right, if we find no oil, then we lose money. That's a straight up loss. You drilled, but you never found anything. Now, sometimes when we lose, it's still a positive number because, we're gaining money, but just not as much. But here, if you don't find oil, you just spend all that money to drill and you didn't get anything. So this is going to be negative. But I warn you, it's not always negative. It depends on the problem. So you have to read the problem carefully and figure out, are they talking about high profit versus low profit, or are they talking about profit versus loss? In this case, it's loss. All right, now the probability of finding oil, so getting the good stuff, is 0.2. Not necessarily good for the climate, but good for your pocketbook there. All right, and that means this has to be 0.8 because, of course, these are complements. This is all there is. Either you find oil or you don't, right? So let me just write this down. Find oil, no oil. And that'll be the case for all of these. So those two, find oil, no oil. So that'll be kind of standard. Well, that's it. Those are the only 2 options. So they've got to make 1. And that's why if this is 0.2, which was given, then this has to be 0.8 or 1 minus 0.2. That way they add up to 1. All right, let's make the probability distributions for every site, and then we'll go find the expected profit for every site. So for site B here, we have our profit, and we have our probability. Now site B is going to get 120 million if oil is found, so find oil. If we don't find oil, again, there's a loss. It's negative because you're drilling and nothing's coming out, so that's negative 18. So it's a more expensive place to drill. And the probability of finding oil is 0.1, which means this is 0.9 because they have to make 1. They're complements. All right, last one, site C. I'm just going to color code these here. All right, so site C has a profit and a probability of 70 here and 0.15, and then negative 5 and 0.85, right? Because 70 if you find oil, and there's a probability of 0.15. Loss, again, that's negative, of negative 5 and a 0.85. All right, so now we want to go find the probability, the expected values, of every single one of these. So we're looking for the mean for site A, and then the mean for site B, and so on. All right, that'll be the expected value. So when you see expected value, expected profit, that would be the mean. All right, now we could go find these a lot of ways. We have 3 different ways we could do these. Number 1, these are actually super easy to do by hand because remember the by hand method. It's just take your X, probability, times, your profit times your probability, 0.2, plus, well actually in this case negative 10, so minus 10 or negative 10. You have to use that little negative sign if you're on the calculator, and 0.8. That's it. That one's going to be 8. Now let's find it with the stat edit method if that's more comfortable for us. So we would clear out these old numbers here. And then type 80. Make sure you use the negative sign on the calculator, which is down here. Negative 10. And then over here on the right, 0.2 and 0.8. There we go. Stat, calculate, one variable. Make sure you have your frequency list on. Get your freq on with L2 and go to calculate. And there it is at the top, 8. Now in StatCrunch, which I like the best, of course, so if I would just say profit A, probability A, that way I can keep these all straight. So 80, you can just type -10, just like you would, not 0.10, -10. There we go. And then the probabilities were 0.2 and 0.8. You go to Stats, Calculators, Custom to the bottom. Say profit for A, probability for A, and click Compute. And all you need is that mean right there, the 8. That's all you care about. Although, interestingly enough, the standard deviation is 36, which is amazing. So one way or another, we learned that's 8. And of course, this is talking about drilling for oil. So this is $1 million with a $sign. That's the expected value. All right, so I would do those same calculations again and again in StatCrunch or in the calculator. So it kind of doesn't matter which way we do this. I'm just going to go, I'll do this one in the calculator and I'll do the next one in StatCrunch just for variety. So if I go here, I make these, well, I can just type over them, 0.1, 0.9. These are so, I mean, there's so little here, I can just kind of write over what's there. This is -18. Make sure you use the negative sign. And then this is positive 120. 120. There we go. Stat, calculate, one variable. There we get -4.2. So this one is -$4.2 million. Part of that is because it had such a low chance of finding oil. And then just to show StatCrunch one more time, I'll do profit for C and probability for C. This was 70, -5, 0.15, and 0.85. And again, this is almost more trouble than it's worth. It's super easy just to find it by hand. You just multiply each value times its probability and add them up. So profit C, probability C, compute, and 6.25 is what we get. So there we have it. And again, I'm just going to reiterate this. 70 times 0.15 minus 5 times 0.85, same thing, right? So it's kind of more trouble than it's worth to bother putting it in a table when the table's this small. But if you're comfortable doing that, then that's fine. So 6.25, and this would be $1 million as well. All right, so we found all of our probability distributions. We constructed them for each site, and then we found the expected profit for each site. Okay, now the tricky bits. We want to look at what we would do if the CEO is an optimist. An optimist is a person that ignores the probabilities and just thinks the best things are going to happen for them, right? So they're going to believe the best things are coming for them. You know, good stuff is coming their way. What can they do, right? So let me just say an optimist ignores probabilities, ignores expected values, ignores everything we just did. And just looks for the biggest payout. The best profit. And goes with it, right? They're a gambler, right? An optimist is another way of saying a gambler, a risk taker. That's an optimist, right? They're going to ignore statistics. They're going to ignore all the negatives and be like, I'm awesome. I'm great. Good things are coming my way. Okay. Well, let me color code this for you. It's B. Now, why is it B? It's because of the 120. So they're going to ignore everything. They're going to look at big money. 80, 120, 70. 120 is the biggest. That's me. I'm a gambler. I'm a risk taker. Awesome things are coming my way. That one's going to be mine, right? So it's because the 120 is the highest possible payout. And that's all they're going to look at is the highest profit. That's what a gambler CEO does. They look at the highest payout. All right, now what about a pessimist? Well, a pessimist is worried about rainy days, right? So they're going to ignore the probabilities. They're going to ignore the expected values as well, right? Same thing as the optimist. So they ignore probabilities and expected values and looks for the least bad of the bad outcomes. Because they're worried about the bad outcomes and they take the least bad of them or the best of them. Okay. It's not that you're just trying to hedge against um, bad things. You're trying to hedge against the worst outcomes. So this is a worrier CEO. I always like to joke it's a little bit of an Eeyore, thanks for noticing me. So, so you look at, if you know who Eeyore is from Winnie the Pooh. All right, so you look at the bad outcomes. It's not that, they don't think good things are coming. They're just nervous. They don't want to be out that 18 million. That 18 million would be really bad. They'd maybe have to fold the company. They don't want that to happen. So they go, no, I don't want to lose 18 million. I don't want to lose 10 million. If I'm going to go down -5 million, we can take. They look at the 3 bad outcomes and they pick the least bad of them, which in this case would be the -5. Be like, I can take that. I can take the -5. That's the least of my bad options, right? So that would be, let me preview this. It's going to be letter C. Letter C is that option, right? Because the -5 is the best of the bad outcomes. Oop, this pen is dying. All right, now, last one. What about a statistician? Somebody who's really looking at all of the probabilities and profits synchronized together. They pay attention to the expected value because that is the advantage. They're not a gambler on the good side or the bad side, right? They're not a gambler. They're not a worrier. They're going to pay attention to expected value and probabilities because probabilities are where those expected values come from. Probabilities. I'm having trouble spelling that today. Well, that's going to be letter A, right? So the statistician is going to look at letter A. And that's because the expected value was the highest for letter A. There we go. And I know it seems facetious and perhaps, oh, this is so simple. It is a simplified version, but this absolutely takes place. There are people that make lots of money at different companies trying to help, Google, Facebook, etc., try to figure out where to invest, what kinds of things to do, right? There are people, statisticians and mathematicians that are hired at these companies constantly to help people make big decisions like this. It also works for, gambling games like Who Wants to Be a Millionaire and, well, working at casinos. Casinos hire people that do this as well, right? So pretty much all of your finance and industry will hire people to figure these kinds of things out, as will sports. And that's what the movie Moneyball is about. Jonah Hill is playing the statistician that helps the team figure out what to do. So Moneyball is a very, very good movie, and it's exactly about ignoring what the old school baseball players think about who should be hired and who should not be hired for the Oakland A's, and going with actual statistics, which of course now it's called sabermetrics. It has taken over Major League Sports in America. All your baseball, basketball, football teams, they are all run by statisticians. I mean, not officially run by statisticians, but you better believe everybody's consulting the numbers to figure out who should be on the team and who shouldn't.